adım Bahar. Bir de şimdi ben 6 yaşıyım. Bir de şimdi robotlardan konuşacağım. Bir tane robot var. Onun içine yemek koyacaksın. Sonra düğmeye basacaksın. Sonra çalışıyor. Bir de bir tane daha robot var. Bir de o da köpek. Bir de o köpek çok güzel renk var. Bir de bir tane daha robot var. Bir de o hep süpürüyor yerlere. Bir de o çok iyi yapıyor çünkü insanlara yardım ediyor o süpürgeye. Bir de düğmeye başlıyorsa sonra çalışıyor. Bir de sonra süpürüyor yerlere.
Oké, maar wat zijn robots?
Robots zijn machines gemaakt door mensen die ons kunnen helpen in heel de wereld.
Oké, kun je een paar voorbeelden noemen van robots?
Je hebt mensenrobots, dierenrobots en ja, nog veel meer.
Zijn robots goed of slecht?
Je moet ze goed maken, want als je dat niet doet, dan kunnen ze slecht zijn. Maar als je ze goed maakt, hoef je je geen zorgen te maken.
Wat denk je dat de robots in de toekomst allemaal kunnen doen?
Dingen verzorgen en misschien patiënten opereren. Ja.
En wat zouden ze allemaal kunnen bezorgen?
Pakketjes en eten bijvoorbeeld.
Oké, ken jij een robot?
Nee, niet echt.
Nee, vind je robot eng?
Nee, dat ook niet.
Nee. Zou je het leuk vinden om in de toekomst geopereerd te worden door een robot?
Ik hoop natuurlijk dat ik niet geopereerd word, maar het kan wel.
Oké.
Robots are expensive. They can do tasks that humans can't. My mom works for a robot company. That's really cool. Her grandpa was very sick. His heart was very sick. A doctor and the robot saved his life. I think more people need to learn to save people's life. I'm not afraid of robots. We're not afraid of bicycles because we steer them. Same with robots, we steer them. Simple.
我叫陈浩宇。我知道的机器人有机器人玩具，例如机器猫、机器狗、T-Rex 等等，这些都很有意思。还有一些机器人很恐怖，特别是一些跟人类有一样的面孔，特别恐怖。
你觉得机器人可以做一些什么事情呢？
机器人可以，除了当玩具，还可以当人类的助理、向导等等。
那你觉得机器人在未来可以做一些什么事情呢？
未来的机器人还可以帮我们做房子、指挥交通。
还有呢？
给摩天大楼擦玻璃。
为什么这些事情要机器人给我们做呢？
因为这个工作很复杂或者危险。
你觉得机器人越来越先进是好事吗？
机器人越来越先进也未必是好事。
为什么呢？
因为机器人可以做好事，也可以做坏事。因为他们越来越先进的时候，他们可以做越来越多的事情，我们就变成越来越懒惰。最后机器人也可以统治整个人类和世界。这当然不是我们希望的。
Привет, меня зовут Соня, я из России. У меня дома живет собака. Его зовут Юлик. Юлик летом линяет, и поэтому с него на пол сыпется много шерсти. Также у нас дома есть робот-пылесос, который подметает эту шерсть и очень нам помогает. Я вообще считаю, что роботы – это будущее.
Ik denk, als ik het woord robots hoor, dan denk ik aan een machine die net zoals als een mens die kan lopen en die armen en benen heeft. Maar van binnen denk ik dan gelijk aan een computer die bestuurd wordt door mensen. Ik denk dat de robots wel goed zijn, want ze zijn veel preciezer. En als er meer mensen zijn, dan gaat alles sneller. Dus als de mensen worden vervangen door robots, dan kan het misschien ook sneller zijn. Maar ook omdat het dan ook weer preciezer is. Maar aan de andere kant weet ik niet zeker of de robots zo goed zijn. Want we denken wel dat de mens slimmer is dan de robots of dat de robot slimmer is dan de mens. Maar dat weten we niet zeker, want we weten genoeg over de menselijke hersenen, maar niet genoeg om een robot te ontwerpen waarvan de hersenen even goed zijn als die van een mens. Maar er was bijvoorbeeld een keer een filmpje en daar hadden ze 2 robots naast elkaar gezet. En ze begonnen opeens te praten over wie als eerste de aarde zou verwoesten. Maar dan willen we niet hebben dat de robots de wereld over gaan nemen van het mens. Ik denk dat de robots heel goed kunnen zijn voor de patiënten, omdat ze ons heel goed kunnen helpen met allerlei dingen. En ze kunnen dingen doen die bijvoorbeeld, ze kunnen zulke ingewikkelde dingen doen die bijvoorbeeld een mens niet kan. Maar als er bijvoorbeeld thuis een oude vrouw is en je zet daar een robot neer en de vrouw heeft hulp nodig, dan kan die robot wel helpen. Alleen die vrolijkt niet de vrouw op, want een robot kan niet echt goede emoties tonen. Wat brengt de toekomst? Nou, hopelijk kunnen de wetenschappers dit in de toekomst ons goed laten zien.
All right, I hope you enjoyed that video, and I think it gives us some insight into what the young people in our world are thinking, and maybe that is more reflective than we know of what everybody around us is thinking, especially our patients. I thought it makes sense to start by going down the line, and our guests can introduce themselves briefly, tell us which company they're from, briefly what their company is doing, and then we'll start with some questions.
Hi, everybody. I'm Steve Adler. I'm CEO of Catheter Precision. We have 2 products in the cardiac EP space. One you heard from Tamas this afternoon, the Vivo non-invasive localization system. And then maybe a little bit of a surprise to everybody, we also have a robotic device that Sabine mentioned early this morning called Amigo that we hope to revive at some point in the future. Thank you.
Mike Iversen, so I'm the Chief Commercial Officer at Acutus. Acutus, I think as you all know and we've seen today on several occasions, is a 3D non-contact mapping system that uses a combination of ultrasound to map the anatomy and then electrical sensing to map the electrical activation field.
David Fischel from Stereotaxis. I joined Stereotaxis because I think we can build it into the intuitive surgical of endovascular surgery. We are the global leaders of robotics in endovascular surgery at this time. We're fully focused on EP. And what motivates us is the fact that, as many of you showed today, you're able to treat patients in ways otherwise impossible without our technology. And we view ourselves really as partners with you in improving patient care in EP.
Thank you. John Pavlidis with Vytronus. We offer a very novel integrated platform that images as well as delivers ablation energy to the tissue using low-intensity collimated ultrasound that both images and delivers energy at the same time in a very patient-specific fashion because we see tissue thickness, and we also feature robotic navigation to precisely deliver continuous lesions along a user-defined path.
My name is Eugene Crystal. I'm a president of Society for Remote Cardiac Navigation. I'm professor of medicine at the University of Toronto, and I'm very humbled to be on this panel.
So I'm Tamas Szili-Torok, electrophysiologist in Erasmus Medical Center, using robotics since I think 2008, and I will be one of the moderators of this discussion.
And I'm Peter Weiss, and soon to be of Banner University of Arizona Medical Center in Phoenix. Again, long-term robotic user, and like Tamas and Eugene, an active member of the Society for Cardiac Robotic Navigation. I thought it would make sense to start off with asking our panel, and taking a cue from the video that we just saw, the real emphasis on safety and how we will be able to improve the care of our patients from that perspective. Certainly there's a sense of excitement about robotics in the future, but also maybe a sense of trepidation as well, that the human element will be taken out to some extent and replaced by the cold technology. How do you feel like you can respond to us and then to our patients through us about that aspect of things?
Sure. I found that fascinating. I found the disparity between some of the children speaking of the concerns, almost the science fiction aspects of the giant robots taking over the earth and how scary that would be on one hand, and the others looking at robots in terms of helping and aiding people, and in terms of doing things that maybe they didn't want to do, like cleaning the room. The vacuum that's right there was just fascinating. And I think that that's more representative of what robotics can be. I think it's many years in the future, and maybe quantum computing and things like that before robots can really get to a higher stage. I think it's more likely that they're aids to people. And I think the systems that you have now, such as the Stereotaxis system, are, far along ways to help you perform procedures better with better outcomes. Sure.
I think from our perspective, it was interesting to watch the kids, right? One of the things that they brought up repeatedly was precision and consistency, right? Several of the kids, I think, talked about that. And when you think about what robots have been, they've come up in the industrial world, it's been all about that, right? It's been being able to perform specific tasks in a very consistent manner over time. And so I think as we at Acutus think about how our technology, specifically our imaging technology, can help with what Stereotaxis does and really advance the field, the patients, is provide better imaging and guidance for those tools that allow the physicians to potentially have more consistent, I think that was mentioned in some of the talks today too, right? Just a better and more consistent approach during the surgeries that they're doing. And I think that's how we see where robots can have a huge impact. I don't think we live in the fear that they're going to take over, but more actually be an extension and provide a more consistent outcome across the field.
So exactly as Steve and Mike mentioned, really what we view as the benefit of our robotic platform is the safety and the precision and the consistency. So that's that. I wanted to touch a little bit upon the comment that you just made, Pete, about robots maybe taking out the human element and making it a cold. The technology makes the procedure more cold. And I can almost challenge you that on the opposite, actually, robotic technology allows you to reintroduce the human element in. And if you think about your role as a physician, there's the aspect of treating the patient, trying to understand the disease, trying to speak with the patient, trying to deliver the best care. And then there's the mechanical aspect of, once you know what you want to do, how do you execute that? And when your entire focus is on the execution, you lose sight of the fact of how do you do the best treatment? How do you engage with the patient the best? And so the more that we can reduce the difficulty and challenge of executing what you want to execute, it allows you to actually spend your time on treating the patient, on thinking about the patient, and that's ultimately best for the patient. It's also best for you. It allows you to be actually much more of a human in the fuller sense of the world than when you're focused on mechanically moving a catheter.
Yeah, that's a great point, and to build on top of what David said. But before that, I want to make a comment. It's clear that the kids have also been obviously influenced by Hollywood. So when we think of robots, we think of Terminator. Perhaps we think of drones with missiles on them and things like that, which are certainly not for human safety. So when you take that out and you really focus on medical robotics, the opportunity for increased safety is tremendous. And when you have technology that senses its environment, knows exactly where it is with great precision in a beating heart, and has very strict boundary limits, does not get tired, does not get distracted, all those really lead back to reproducibility, safety, higher accuracy, and greater consistency. And we go to bed every night thinking, how can we make our technology even safer? And because we recognize that safety is paramount, and that's an area where robotics can actually lead instead of follow. And overall, we really view medical applications of robotics as enhancing human capabilities, not replacing human capabilities.
And how do you see that, Eugene, from the medical specialist point of view?
I think my first comment, look at these kids, and I'm going to agree with Steve, is, you know, kids are actually looking for robots to do things they don't want to do and they don't want their parents to do. Most of us operators do want to do what we actually do. But I think the most striking part to me after this movie is to remember, you know, every time I'm coming to the short stay and I see a patient who is going on the table. And about 50% of them are asking, oh, did you have a good sleep? Or did you have a good rest? And it's not that I'm looking that bad, but my point is, internally, I care much less about what did I sleep well or I didn't, because I know that the precision and the guidance of the machine will frequently, you know, save the patient from complications and me from, you know, dragging procedure for too long because I feel that I need to be more careful because I feel not well, etc. The electrophysiology in particular is famous for very long procedures, extraordinary long and demanding procedures, and I think having machine on your side to deliver better care, that's the only way to go in the future. And that wave of innovation, the innovation of automation and robotics, is radically different from everything else we did before. It's different from 3D systems, it's different from the mapping, it's different from contact force. It's literally changing the way we do. I think that's the way I see it.
For me, it was also amazing that these children, they were independent from each other. They never talked to each other, and they raised very similar issues. So let me to go back a little bit to this robots taking the world from us issue, because I think it's still a very important factor, because in our congresses, we always talk about the adoption of the technology, and it seemingly in the last few years there is a problem of adoption of the technology. What do you think? Is this thought plays a role in that, or it's related to completely different factors? For instance, that at this moment the medical robots just simply not performing enough.
So I think kind of your view is a little bit skewed because you're in electrophysiology. If we step back a little bit and view surgery and medicine from a broader perspective, actually we're undergoing an amazingly rapid adoption of robotics. You'll have now about 1.2, 1.3 million robotic surgeries performed this year alone. Obviously, the Da Vinci system in laparoscopic surgery is the primary system, but also in orthopedic surgery, in hip and knee, and spine surgery. The Da Vinci system is now used from urology to gynecology to GI surgery to ENT surgery to thoracic. So you actually we're living through actually a revolutionary period in terms of robotic surgery. I think there's company-specific, industry-specific dynamics that impacted the adoption in electrophysiology, but that's unique. That's a unique story to Stereotaxis' history, and I think it's less so a reflection of adoption of robotics in medicine.
Yeah, just to add on it, and it's just amazing the growth of robotics in the field, and I think that one area that we've been pursuing with a strategic partner is a more of a remote type robotic solution. And I think, again, this adds, I think, another level to patient care. Of course, it has to be done carefully and it has to be done safely. And that is to be able to deliver high technical electrophysiologic solutions to places that don't have you, that don't have the electrophysiologists available. And I think that that's going to be an exciting area for the future.
I think for our part, you know, we view the opportunity with robotics, or maybe the lack of implementation in EP so far, is, you know, it's about information, right? It's about data and providing better guidance. And so as we look at our technology, we believe that it allows the democratization of the mapping process, right? So the gathering of the information that allows you as a physician to focus on the actual treatment, because really we make a great diagnostic tool that hopefully gives you better information to treat your patients more appropriately, right? And so we view that as a key aspect of a broader adoption of the robotics, is if we can simplify the diagnostic process and have you focus more on the actual execution of the treatment. And we think that together with our partners like Stereotaxis, that we can actually increase the adoption of the robotic in EP.
Yeah, the only things I could add are, number one, that there's a true explosion of robotics everywhere, and in healthcare. And you see that obviously not only with the market leader Intuitive Surgical, but J&J making tremendous investments, Medtronic about to enter the surgical robotics space, and just millions of procedures being done with robotics. Every field has the usual adoption curve. So you have the early adopters, and certainly this room is full of those in electrophysiology. And those are the pioneers who really believe in the vision, even though a lot of things still need to be worked out. And then you have people who say, well, I like what they're doing and I want to follow. And then you have some of the laggards who say, well, I guess I have to have what everybody else has at the very end. So there's a normal adoption curve. We are actually big believers not only in robotics as in teleoperation, but also in some built-in intelligence and, if you will, some autopilot modes for robotics. Of course, you need to have the safety precautions for that, but when you have a system that can automatically create the maps, when you have a system that can automatically trace a path that the operator has defined with extreme precision, therefore enabling a complete shift of the performance curve to the right, so making everybody better and reducing the standard deviation between operators. So that's one of the key visions of robotics, and when you have some intelligent autopilot modes, you can basically have similar effects to what autopilot did for aviation. Safety increased by a factor of more than 5 times once you implemented radar and autopilot. And the opportunity is the same in medicine.
Yeah, I think that's a good segue into my, I guess, continuing thoughts about this. There seems to be a bit of tension between seeing what the children also have as a bit of an expectation that robotics will be part of their world, right? Yet at the same time, especially in cardiology and electrophysiology, a slow adoption, even in comparison to other areas of medicine. The robotic, laparoscopic, and similar surgeries like prostatectomy have up to a 90% penetration rate already in robotics. Yet within cardiovascular space, it has been much slower. What do you take as with the tension between the sort of reluctance to adopt within our particular field compared with some of the excitement that led to early maybe uptake in some other fields of medicine, and how does that contrast with the expectations of our patients and the bigger world out there that robotics will be a very big part of their world going forward?
I mean, for me personally, and I think as we think about it, there's a couple aspects, right? And one that we haven't touched on so far is probably cost, right? So as we look at the medical field, certainly in Europe, as well as in the US, cost is becoming more and more of an issue. And these robots and our systems are still relatively expensive, right? So that's probably one inhibiting factor, is that many facilities just don't have the ability to take that on. And that's certainly a challenge that we face.
There's a range, right? We can go into a long kind of almost Harvard Business case study review on kind of why adoption of robotics hasn't been as high in EP, and I'm happy to go into more of a detailed review like that because that's to some extent what I did prior to joining Stereotaxis. I think though sometimes there's explanations, and sometimes you search for explanations when there's just a fact that emerged. And what you oftentimes have in life is that adoption or things happen because they get popular. And once you hit a certain adoption curve, it just everyone shifts over, right? The clinical value of of robotics in prostatectomy, for example, is not particularly high. And the cost factor is the same there. And if anything, EPs make much more money for a hospital than a urologist makes for a hospital. So you would think from a cost perspective, from a clinical values perspective, there's many reasons why it shouldn't have been adopted in urology, and it did. Sometimes what happens is you hit a critical mass, and then it becomes the popular thing to do, and then it takes a life on its own. Again, there are all sorts of fundamental things we can talk about, but I'm not sure it's particularly driven by the cardiologist. It might have been driven more by specific company, technology, industry dynamics that just kind of didn't allow Stereotaxis to reach that tipping point where then kind of everyone becomes a fast follower.
So I think there are several dynamics that really impact adoption curves. Number one, it's really the difficulty of the application. So let's face it, cardiac applications of robotics are very, very challenging. And let's not forget, we now take it for granted that Intuitive is so huge. But as they famously have said, they aimed for the heart and hit the prostate. Right? So it's the original application for cardiac surgery, robotics, was for the heart. And that did not exactly have a great fast adoption curve. So it reflects the difficulty of cardiac applications. It reflects cost aspects that were also mentioned by Mike. Our view is that the ideal robotic system should not require a tremendous amount of capital up front. It should not require dedicated rooms necessarily, and it should be affordable by all. On top of that, some past examples of lack of success have really been due to the lack of integration between the imaging and the therapy aspect. If you need different devices to do different things in a robotic setting, then it increases the complexity. And yes, maybe a few people adopt it, but a lot of people would rather stick to what they are comfortable with, right? So you always have to overcome a certain comfort zone and prove the value proposition. So integrating imaging and therapy, we believe, in the same device is very, very important for medical applications.
Could it be that the other issue is that when you look at cardiology, it's quite diverse? And electrophysiology is a relatively young subspecialty. Mm-hmm. And when you look at the where most of the patients are out there is in interventional cardiology. So there is no driving force behind it in terms of, or it was until we started to treat atrial fibrillation. So actually that's why we could have a delay in this. What do you think about that?
Well, it's a big area, right? In terms of the adoption. I'm sure we'll have a long discussion on this. But there's certain boxes to check, right? And it's it's outcomes, obviously. Not only outcomes for the patient, but outcomes for the physician. So that's of course what's key here. Procedure time. That's probably something that some of my fellow CEOs here are thinking about and focused on in terms of, because that speaks to cost, is time, and that's probably something that should be improved over time. Now, on the other hand, procedures without robotics takes pretty long as it is. Training. The people that you have in a company that are important in terms of their support to the physicians and the training to the physicians and the sites are key that the technology can be transferred from the company to these sites. These are all key aspects of adoption of a new product. I mean, there's so many products out there that have been great and they look fun, they're exciting and all that, and have never made it. But that's not the case here. These products will make it. There's a true need. It's just, the aspect of time, like you mentioned.
I agree with you, actually, Tamas, that this specialty of electrophysiology makes robotic applications even more demanding and difficult. First of all, it's an extremely complex disease. Right? It is, you have electrical activity. Most of the tools are really 2D tools in the 4D world. There is aspects of learning curve with robotics. Do you need 50 procedures to get the hang of it, or do you need 3? Right? And this is obviously something that really concerns all of us in industry. How do we reduce the adoption curve, make the learning curve shorter? Procedure times, our system was mentioned earlier, and early on, certainly that's been one of our challenges. We now see a path to easily sub-2-hour procedures, and even for persistent patients with multiple lesion paths, isolation of the entire posterior wall and all 4 veins with less than 30 minutes of ablation. But when we started, if we didn't have tremendously patient investigators early on in Prague and then at Erasmus, in London, in Frankfurt, and in Coburg, we wouldn't be where we are today, because we have to listen, learn, and deliver, and it always takes some iteration to go back so we can continue improving. But a very difficult application like a fib or VT or so on requires some learning curve iterations that take time and money and lots of patient investigators. You can't do these things overnight.
Tamas, you were exactly right. When you have a boring, standardized field, it's perfect for robotics. It's ideal for robotics. EP is the opposite of that. It is highly dynamic, and what each of you do in your labs is completely different than what any of the other one of you do in your labs. I'm exaggerating a bit, but I go to each of your labs and I see what you do, and it's amazing how unique each one of your procedures are. And that makes it very difficult actually to build a standardized robot that just does the same boring routine thing, which is what to some extent robots are designed to do beautifully. So the dynamism of EP and the diversity in the ways that you all still treat disease does make it tougher for robotics to become adopted. And that's why we have a robotic system that is fairly flexible. It allows you to really do whatever procedure design you want to do, you can do it, and it just is kind of an extension and enhancement of your own capabilities. But if EP at some point becomes much more standardized, where we know for paroxysmal AF, you just do this, and for PVCs, you just do this, and you do it as a routine in a robotic fashion, kind of that's when it would make our life much, much easier to design a solution that really is kind of in a cookie-cutter approach perfect for you.
I think your point, Tamas, about the youth of the field was an important one, right? Dr. Ernst's talk earlier today, where you saw the timeline of innovation and kind of what's happened in the ablation field. I think a lot of the focus, and if you look at the community as a whole, I think, like David said, we all spend a lot of time in a lot of EP labs, right? You're in your own labs, and no doubt the folks in this room, I think as someone said earlier, you are all early adopters, and you're at the head of your field, right? So there's, I think, 3,000 EPs in the US, and if you've seen one EP lab, you've seen one EP lab, right? And everybody does it differently. And the advent of mapping and then the usage of mapping, a lot of creating really good maps takes operator skill, it takes time, it takes dedication, right? Applying great lesions to those maps takes time, takes dedication. And so I think you've seen a real acceleration of the treatment, especially of paroxysmal AFib with the advent of cryoballoon, right? Because what did it do? It made a procedure that was relatively complicated and took a lot of skill and time and effort, thus automatically limiting maybe the field or the application or the usage of it more broadly, because you had a lot of community guys that maybe weren't tackling it, didn't have time for it, didn't want to venture into it. And with cryo, that's changed, right? So to David's point, when we can get to a point where the treatments that you want to do for certain patients become standardized and everyone does the same thing, then we can probably see a much broader application for robots, because now we can design and build the tools that specifically apply to that procedure and makes it repeatable and allows you guys to focus on the super complex stuff, right? And taking away that very simplistic stuff that needs to happen.
Having said this, anybody of you thinks that in about 50 years, just a short run, and human hands will touch catheters in treating patients?
Not a chance.
I don't see that happening, yeah.
I would see 50 years as too long. I also have another question regarding the complexity as well. So, you know, we've begun to think about things like cryoballoon, and that have really been able to take some of the routine aspects of what we do and make those easier in a sense. Unfortunately, and maybe this speaks somewhat to the complexity of our task as opposed to just taking out somebody's prostate, it's not clear the patient outcomes have really improved all that much, right? That we still, even, you know, for something like atrial fibrillation, even paroxysmal atrial fibrillation, with a quarter to a third of patients coming back for second procedures, et cetera, that just doing those routine tasks doesn't seem to necessarily be enough. I'd love to hear your thoughts about what is necessary in addition to just the robotic manipulation of our tools, that bringing in machine learning, artificial intelligence to actually not just help us do what we're currently doing better and more easily, but to actually help us go beyond that to improve patient outcomes and get beyond what seem to be some of these ceilings that we're reaching as far as success.
Well, I think, you know, from our perspective, it's been interesting to us to look at the field and you know, when we look at why Acutus was kind of created and why we do what we do, right, is it's an interesting dichotomy to think about, and I came out of the device world for a long time, that you bring a patient into a lab to treat an arrhythmia, and the first thing that you generally do is take them out of that arrhythmia, right? So, I mean, if you think about a lot of other surgical applications today, what application do you bring a patient to treat them for something, and then you don't really want to actually look at it, right? I mean, in cancer, the advent in cancer is, you know, when you're doing breast surgery, you're going in and then you're checking the margins and you're making sure that you actually did what you needed to do before you get out of there and close the patient up and go home. In AFib, it seems like even with the current mapping systems as a state of play before we came into the field, you couldn't actually see AFib, right? So you were using markers or slow conduction or other indicators to hopefully try to diagnose what was going on, to see the underlying. And I'm not saying we have it all figured out, right? But I think for the first time we're at least providing the field with a tool where potentially you can start to see some of what's happening. And that'll help you treat that. I think that's going to evolve, and we're going to have other competitors that are going to, you know, we heard about some of those today that are going to do similar things, right? But in order to kind of get to what you're talking about, I think one of the first things we have to do is get better at actually visualizing and imaging that and giving you the information so that you can treat it better.
Okay, so this is a bit self-serving, I apologize. But I think about the product we have, our Vivo product, as a localization. And by having that computerized information available prior to a procedure, you know, will give you additional information and additional knowledge going into the procedure. Now, right now, again, we're focused on ventricular arrhythmias, but this gives you one other piece of information that you didn't have before for you to sort of run a more effective procedure in hopefully a shorter amount of time. So I think that some non-invasive systems like Vivo, like the EP Solutions product, Cardio Insight, InHeart, this is a new field that's opening up from multiple companies that's providing more information to you to help guide the procedure, and I think that will aid it quite a bit.
On one hand, there's two opposing forces. We really are trying to standardize a very complex procedure, and because if you cannot standardize, you cannot really democratize and make everybody better. So standardization, objectivity are one aspect. On the other hand, we know that the real solution, because the results still need to be improved, has to involve patient-specific therapies. Not one-size-fits-all balloons, not one-size-fits-all dosing. or energy delivery systems. And therefore, if you can have, and that's why we're so excited, obviously, about ultrasound, if you have an imaging modality and a therapy delivery that can see the tissue thickness, can characterize motion, and deliver energy really titrated to that patient's tissue thickness and motion profile in that particular region, then you have the opportunity to, on one hand, standardize and objectify the workflow. On the other hand, make that treatment very specific to that patient instead of assuming that the same energy setting, the same balloon size or whatever will treat everybody. So we think that's the balancing act in solving this very difficult problem.
Pete, the way when I was listening to you, I thought perhaps you were trying to go a little bit broader in terms of big data and things like that. Somewhat. And so I guess maybe that's how my mind was suddenly flipping on kind of when I heard you. And I think kind of when I look at robotics, I think that there's actually two really distinct kind of classes of benefits that you want to try to, that are provided, but that you want to try to work on. So when I think about kind of how you want to improve the technology, it's within these two big broad classes. And one is the mechanistic capabilities. So by navigating from the tip, you have precision and stability and reach, and you have a safer catheter. And that's kind of one, it's a mechanistic benefit to robotic navigation. It's not possible with manual catheters, but that's its own, it's a mechanism. The second benefit is this concept of digital surgery. And what's interesting is if you look at kind of the spectrum of kind of learning, you can have heuristic, siloed-based learning, where you're alone and you're learning based on your own heuristic, or you can have kind of data-driven and kind of from a communal, taking big data from many different sources, and that's kind of the two ends of the extreme. And in medicine, what's interesting is we're still doing many things based off of heuristics. You do a few cases, you see how you feel, how those patient outcomes were, and kind of your opinion on the technology is driven by that. And we do have meetings like this, and we have all the societies, and we have all the medical journals which try to kind of break down the silos and allow for sharing of information. But in many ways, it's still a heuristic-driven approach. The beauty when you digitize surgery, which is possible only through kind of robotic mechanisms, is that you start to build, and Stereotaxis has not really done this in any dramatic way yet, but kind of it's what we're thinking about, is you start to build a capability to aggregate data from hundreds or thousands or so of sites and procedures, and then to start to analyze and start to incorporate data. If you can save the data in standardized forms, right, you can start to learn from that, and you can use, people were talking about neural networks earlier. And so that's kind of a whole completely different class of thinking about robotics and the capabilities that should provide, that kind of is out there. With that comes things like telemedicine and connectivity. There's kind of all sorts of things there that are this digital surgery realm. And so I think kind of splitting your mind and thinking about the mechanistic benefits and how to continue to improve those and how to work on those, how to think about digital surgery and what that allows and enables and how to work on that, that's kind of how my mind works.
That's a great point, and I just want to emphasize something. All robotic technologies have this tremendous ability to store a tremendous amount of data about every single second of the procedure. We know exactly where the device is, we know what's happening, we know the rhythm, we know motion, all these parameters, and we're just scratching the tip of the iceberg as well, but everybody in the robotics has the opportunity to really, really mine the data and create machine learning algorithms to really improve exponentially. And every new technology initially gets what? Underestimated, poo-pooed, right? And then it improves so much faster, and before you know it, you have the next Nokia or the next Kodak, because they were so comfortable in what they were doing that they missed the boat on a new wave.
So thanks for this part, and it was really interesting, and this was triggered by the children's movies, but now we reached the point when we also would like to have questions, or accept questions from the audience. I would like to ask the first panel person who answers the question to repeat the question. That's for the recordings. So please feel free to ask questions that you can address to the representatives of the industrial partners.
we are referred to early adopters. What is the normal curve for the adaptation? Because if I've been using Stereotaxis for more than 10 years, Sabine even longer. I've been doing AFib ablations for 20 years. She's doing even longer than that. What is the normal curve for the adaptation? Things like that. It sounds a little bit funny.
I agree with you, and so I think that the adoption curve that was mentioned, that's for a typical product. Stereotaxis' history and setting does not match the normal adoption curve because of some of the company-specific, industry-specific, technology-specific dynamics. One of the things that I loved about Stereotaxis when I started to learn about it in due diligence is that I saw that on the one hand we had EPs that were leaders in their field and were from great university hospitals who were using our technology. And on the other hand, we had physicians from small towns and small local hospitals that were using the technology on a regular basis. And that tells you that the adoption, usually early adopters adopt something just because it's cool and sexy and new, and they want to be the first ones to have it. And I think Stereotaxis had that in the early days. That's what drove a lot of the adoption at initial sites. Over time, you can't sustain usage based on sex appeal and newness and that. What ended up happening is that some users, many users, ended up realizing that, wow, this actually is great for me and it's great for my patients, and I continue to use it. And then you had sites that realized it's great for me, it's great for my patients, it allows me to build a successful practice, it allows me to treat patients that otherwise wouldn't get treated, right? It's good, we should adopt that. And so kind of you have actually now, when I look at our 110 hospitals globally that are using this technology and let's say 300 or so physicians, it's actually a very diverse group, and they span from those that would be typically in the early adopter phase to kind of the later adopters to even kind of the ones that typically are stragglers, because again we're a little bit of an interesting dynamic there.
All right. So the curve must be long. And I have another question there. That you were referring, for example, that there's no standardization for atrial fibrillation ablation. Most of the cases we're still doing, even if it is growing and growing and other things. SVTs are the most common, and it's very, very standardized techniques for SVT ablation. The companies are not interested at all developing anything for those. I've used the Stereotaxis treating SVTs. It's very convenient. It's very simple. Is it only money driven for the companies now that you want to be in the area which is growing rapidly, forgot the standardized treatments?
I don't think it's money driven. I mean, not for our sake, right? I mean, obviously we're not an altruistic entity, right? We're here to make profit. I mean, there's no doubt about that. But in order to advance the field and provide better therapies, we have to make money. With that said, clearly we want applications so as we look at our system specifically, I can't speak for the other gentleman on the panel, but as we look at our system and launching it, right, our system was created specifically for persistent AFib initially. Over the last year and a half, we've morphed that into really wanting it to be a standalone EP system that you can use for every procedure that you have. And we're adding in contact mapping, we're adding in a time-gated usage that we're calling SuperMap of our non-contact mapping application, right? So with the goal of giving you a visualization and imaging tool that you can use for every arrhythmia that you're going to have in your lab. We're also adding all the other tools that are required during an ablation. And our goal is to always provide you with hopefully the newest and the best technology that we can possibly find for any procedure that you want to undertake with our system.
Yeah, so the only other comment I would make to answer that question, which is, do we really focus on only big markets, right? Or is, of course, the size of the market is an important driver toward wanting to enter it. At the same time, it's really important, are you going to be one of 25 companies, or can you be the clear leader even if it's a smaller market? So what everybody tries to do is to really have a platform with multiple applications, right? So as a startup, one of the challenges, you have to focus. So our sense of focus has been on atrial fibrillation, but we also think our approach can be very powerful for VT, can be very powerful for actually renal denervation without needing tissue contact and having different robotic mechanism. Can be powerful for anywhere where you are in fluid, whether it's blood or other body fluid. So, but the size of the market is definitely a key driver, especially when you're looking for investors who look at market opportunity before they decide to fund.
If I could just add a few things, and getting back to your first question also. Unfortunately, things take a lot longer than you really want them to be. The years of Stereotaxis, I know it seems like a long time, but to me, it doesn't appear to be a long time. Maybe I'm just getting old. But I've been involved now with multiple startups, and every one of them, we've always felt going into it, we set a timeline, it might be 3 to 5 years to some exit, but the reality is it always takes longer. Maybe the problem is me, I hope not, but it always seems to take, we're in a regulated environment, there's many other factors that are involved in the time that these ventures take. Yeah, so, great. And the financial aspects of it, yes. So that is a consideration, especially for a startup. I mean, obviously you have to be the right market to attract the investors and keep your shareholders happy. But in another case, for example, in our company, we're starting out in the VT market, which is the smaller part of the EP market compared to AF. If we were going after AF, I think the investors would be, much happier to be after that first. But it fit for us better to enter a less crowded space. So that's how we followed that pathway.
Pekka, coming from the investment world, so kind of with that mindset in mind, it's less driven oftentimes by how big is the market, where's the money. It's really, if you think about what's the clinical need and how likely are you to solve that clinical need, how significant is the clinical need, the unmet clinical need, and how likely are you to succeed in solving it, that is actually the driving force. Because sometimes a market doesn't exist, but if you recognize there's a significant unmet clinical need and you can meet it, then people will pay for it, right? The market will evolve and will become real there. So I think the question is, you can flip it and say, is there really, in some of those procedures, is there still a significant unmet clinical need? And if there is, and you think that kind of industry is ignoring it, then that's the beauty of these relationships, is that we hear from you where there is unmet need, and we can learn from you on how potentially there's ways to treat it.
When I look at the field of EP, for it to be successful, there are like 4 steps in every procedure that you have to have. You have to know the mechanism, you have to be able to map it, you have to navigate there, and then you have to deliver the whatever technology you have for ablation of it. And if you look at different aspects of this for different arrhythmias, so first look at the AVNRT, for example. So we kind of know the mechanism, navigation is easy, mapping is very easy. So there's really not much challenge left in there to require further improvement. And then on the other extreme, you have persistent AFib, which pretty much know nothing about the mechanism or very little about the mechanism. Mapping is decent, but we don't know why we're mapping because we don't know the mechanism. Navigation is a bit challenging, and the delivery is maybe challenging, maybe not, depending on what the mechanism is. And you can have the best mapping system and map the left atrium 5,000 times a second, but if you don't know what you're mapping and what you're ablating, you will never be successful. Now, if you go out of the robotic field, let's say go to manual, for example, if you look at the companies who've been successful, like a J&J, St. Jude, Boston, Medtronic for a short while and stuff like that, the ones who were very successful are the ones who actually focused on all 4 aspects of it, essentially. So for mechanism, they using big data, for example, to find empiric mechanisms for ablation, and they use mapping, multiple polar catheters, stuff like that. Some use different sheets, for example, for navigation, and they have different technologies with different catheters for ablation, and they can work on all 4 of them to get there. And what challenge I see in the robotics system is that we have different companies and they're working on each one of them, and maybe each one of them are doing an excellent job in navigating and mapping and delivering their own type of catheter, but it's not coherent. I mean, each one of them are working on it, and pretty much none of them working on the development of mechanisms for arrhythmia. And I think to move forward somehow. I mean, it's great that all your 4 companies are now today here because you're working on each different aspects of it. But moving forward, I feel the challenge, and Dr. Torok mentioned about the catheters, for example, so 10 years we've been asking for catheter ablation, but the company that works for navigation, for example, may not have stakes in the catheter development, and the company that develops catheter may not have stakes in developing mapping systems, stuff like that. And somehow these 4 aspects have to come under one umbrella for the robotic system to be successful.
And that's why we create nice collaborations like we have between Acutus and Stereotaxis, as an example.
It's very hard for, and especially in the startup world, and your points is very well taken, right? You kind of have to work on all 4 things at once. But I think you said that you got to focus, right? So our company's been around for 7 years now. We're $150 million invested to get to where we are today, right? It's a tremendous amount of money to get here. There's a lot of challenges along the way, both from an R&D perspective, from a regulatory perspective. And so, you focus in on what you think your core application is, and you make that really, really good. And then hopefully you can start to add those other pieces in. I think we realize, right, that, yeah, we can do great imaging, sure. But to your point, what does that imaging mean? We don't know that, right? We don't pretend to know that as a company. We believe it's a journey that we want to go on with you guys. We're working very quickly on collaborating with other companies like Stereotaxis to help with the integration, to add in other products to our portfolio, whether it's therapy delivery or helping you get the catheters to the right spot easier. But also, we realize we have to advance the science, right? This can't just be about advancing the product. We have to advance the science. So we're very engaged and want to work with the EP community as a whole on trying to figure out, yeah, I create this great image. What does that image mean? What do you do with it, right? And then how do we help you get to that, what I show you, once we figure out what it is, how do we help you get there? And when you get there, how do we help you treat it? So I understand what you're saying, but you got to start with your core application. And for us, the core application is imaging.
I'll just try to make a comment on the question and partially related to some other aspects of robotics which were discussed. First of all, we need to congratulate manual operators. The amount of success and the reasonability of the safety existing is not that easy to break. As someone mentioned here, 95% success in SVTs with less than 1% chance of complications. But we also need now to look at the scale, and the scale is huge. So in atrial fibrillation ablation, we're probably ablating 100,000 cases or more annually. And when now you start to translate that amount of patients to what manual operator can or cannot do or inflict, out of 100,000 patients, you actually leave about 1,000 patients with very severe complications or death, and another 1,000 patients with just severe or moderately severe complications. And I want to congratulate at least one of the existing robotic companies, which already bringing these numbers down by 50, 60, 70%. This is tremendous. And it's not that easy to beat manual operators. We're human machines. We went through hundreds and some of us thousands of the procedures before we became what we are. So I would say I wouldn't diminish the mechanistic benefits of magnetic catheters in that respect. I would say they're great. But I would also say that many of imaging or imaging-guided companies came up with very early concepts. And yes, you will have to contribute to science before you will have a very solid landing. But at least one thing you can count on, that there is, the manual operators are already very good, and there is at least one robotic system which can provide you some, safe basis to land on and try to deliver. Similarly, in ultrasound Vytron case, right? You have almost ideal combination of imaging and delivery, and the guided delivery. So I think, there's some positive messages even in that complexity of addressing all 4 goals at the same time.
Excellent remarks. Now we reach the point we have 3 minutes left. So I would like to ask just closing remarks from all of the panelists that you think the most important or the conclusion that you can make from this discussion that I really enjoyed. And I think these discussions can close or can bring us closer together, industrial partners to medical specialists. So thanks for your participation.
I'd like to thank you. Thank you for the opportunity to be here. Thank you for allowing Catheter Precision to be here at this event. This is my first year at this meeting. I've been very impressed with it, and I look forward that we can attend in future meetings and perhaps in a bigger way. And so I enjoyed the meeting. And this type of meeting, the presentations are excellent, the science is great, and you talk about earlier collaborations between companies and products, but it's also what's important to us is collaboration with the scientists and the physicians. And just for me, being involved, the dinner discussions are, have helped me quite a bit, and I've learned quite a lot. So thank you very much.
So I'll echo that. Thank you for allowing us to be here this year. It's great to see the growth in the meeting this year. We were in Miami last year, and a lot more folks in the room this year. So really, really hats off to the committee. I think you guys done a great job growing the meeting. I think for us, like I said, it really is a journey, right? So as we endeavor to launch our Gen 2 device and start to get more and more centers over the next year or more, we invite any of you in this room to come see us or engage with us, help us on this journey, right? We're not in any way saying that we've got it figured out. We haven't. We've hopefully providing a good diagnostic tool for all of you and working with great folks like David on making the whole field better. But certainly from a science perspective, we need input from you guys. We're just sales guys, right? We're engineers and salespeople and trying to bring great products to market that can help you, but we need your help. So to the extent that you want or you're interested, we want you on the journey with us, and we'd love to hear from you with ideas or suggestions for how we can utilize the tool that we're developing.
I also just want to say thank you to SCRN and to everyone who joined. It is really a beautiful organization, and the fact that you guys are so passionate about it, both the organizers, all the attendees, it makes my job very, very nice. I don't know of any company CEO that kind of can look back and say there's a physician society that is really kind of a partner in this journey. And it is an amazing journey. It's an amazing adventure, what we're trying to do. I think when most of those children who are on the screen, when they're around our age, the world will be a very, very different place. And if any of them are in electrophysiology, it'll be a very, very different place. And I think it's really due to a relatively small group of people. The world gets transformed usually by very small groups of people. History is full of all those examples.
Also from my side, thank you so much. We couldn't do what we do without you, and you help both guide us as well as push us to keep getting better. And our mission is, I think I can speak for everybody on the table, on the panel, is any of us or any of our loved ones could be patients. And how do we make better patient solutions? How do we make outcomes better? How do we make procedures safer? Because I'm convinced that, and I think all of us wouldn't be here if we weren't convinced that robotics, navigation, automation, standardization will really thrive going forward and will be a huge factor and an important part of the solution to make procedures and outcomes better for all the patients that are only growing and are in severe need. So thank you for everything you do, and thank you for supporting us.